Welcome to the video in C on arrays. Arrays are contiguous sections of memory that hold the same data elements right next to each other. It's a very convenient way of performing memory and storage in memory, and they're very convenient because we can use an indexer to move through the array rather than having to call 12 or 13 different variables. Arrays do have some limits, and we'll talk about those as we do the coding. I'll see you when it's done. Okay, for this video, we're going to talk about arrays. And navigating through arrays is where you're going to do a lot of for looping. And so I'm going to show you some very, very cool and practical tips to make that process easier as we go. And anecdotally, it's going to make the concept of argv as an input parameter make a lot more sense to you. And then the video we do after this one is going to be on pointers, which will really be of value. I'm going to tell you that this video and the next one are really important that you understand. So pay attention and please practice this heavily, because these are getting into the skills that are going to allow you to write more complex algorithms that do more quality work. So again, I've got my advanced template here. So what I'm going to do is I'm going to do a file, save as, and we're just going to call this arrays. And I'm going to rename it to arrays.c because today my brain does not want to remember the .c appendage here. And I'm going to put up here as my topic. This is going to be Introduction to Arrays. Okay, so we're going to talk about arrays. And an array in memory is basically a contiguous section of memory that has a string of the same data type all in a row, because it allows me to index through that group of variables with an index position so that I don't have to have 10 or 12 different variables located all over the stack of the same data type. If I'm going to keep all of my grades for the semester, I don't need to make 27 variables. I can make an array of either integers or floating points that's 27 places long, if you will. Okay, and it's a lot easier to move through them to calculate an average because I can move in a for loop with an index position rather than have to call up grade 1, grade 2, grade 3, grade 4. So it really is a notational thing that makes accessing these variables or this collection of variables much, much easier. And when you get into more powerful languages, you get into things like array lists and data structures that make it even easier. But we start with the fundamental array, and we're going to start with what's called array declarations. And an array declaration is pretty simple. It looks like this. The type, which is the data type that you're storing in the array name, and then basically square brackets around the size of the array. And by size, I mean how many places you need. Now, one of the rubs with arrays is you can't change the size of the array. Okay, so if you make an array of 8 elements, that's all you get, 0 through 7. If you need to add 2 more elements, you're out of luck. You've got to make an array that's larger and copy those other values into the larger array. It's really a pain. It's very, very painful in C. That's why data structures like linked lists, collections, when you get into object code, are made so that you can dynamically move data around, and all of this memory management is done for you in managed code with data structures that are efficiently coded that make it so we don't have to think about moving individual elements of an array around. Okay, but for now, we're down in the basement. We're still in the crawl, walk, run, and we're in a very old yet small language. So we need to define our arrays correctly. So I'm going to use that example and say I'm going to have an integer array. Now the compiler doesn't know I'm making an integer array yet. It just sees int. But I'm going to call it grades, and then I'm going to go square bracket 5. Now the compiler says, okay, I need 5 integers back to back to back to back in memory. And they're going to be indexed 0 through 4. So remember, grades with a 5 in there means 0 through 4. Okay? Now, I'm going to show you the old school way to initialize what goes in there. Okay, because I want to give them values, right? I want to initialize my variables. So I would say grades of 0 equals, let's say, got an 82 on a test. Okay? And then I would say grades of 1, let's say we got a 84. Okay? And now I'm very quickly going to get tired of typing, so I'm going to say Control C. And I'm going to add 3 more of these. Control V, Control V. Now, this would be 2, 3, 4. And this one doesn't exist. Grades of 5 does not exist. So let's show you that by trying to compile it. Oops. Array index 5 is past the end of the array, which contains 4 elements. Okay? So it just said, nope, nice try, thanks for playing. Okay? Now let's give these different values just to make it easy. Let's go 86, 87, just getting slightly better. And 89 couldn't quite pull out the A. All right. So Control Save. Now let's make it, and it should work. Yep, there we go. Now, it didn't do anything, but I have an array of memory. Now we know an integer is 4 bytes, right? So 4 bytes times 5 elements, this thing takes 20 bytes of memory. Okay? Now, I'm going to show you a shorthand way to initialize an array, and we're going to do an array of characters. That's really cool. If you know the literals that are going into the array, let's make an array of characters. So we've got character, and we'll call it letters. Okay, and we need to give it a size, so we'll give it 5 again, just for giggles. And this time I'm going to say equals curly brace. Now, don't forget the single quotes go around characters, not double quotes. So H, comma, E, comma, L, comma, L, comma, O. Okay, and when I get done, curly brace, semicolon. All right, now I should be able to look through that and understand that I'm going to see H at 0, E at 1, 2, 3, 4 index, okay? So the indexers are 0, 1, 2, 3, 4, all right? But that is an array of characters that has 5 elements, 0 through 4, okay? Now, if I'm going to do a for loop to go through them, in newer languages, there's a method called length. Okay, but in C, I need to actually calculate the length of the array in bytes because it's just not written for me, okay? So I need to know the entire length of memory that this array holds. And in order to know how many elements are in it, I need to know how long each element is. Okay? So here's what I need to know. I need to know how long is the entire array. I need to know how long is each element. Okay? And this is all in bytes. Then I need to know, that will tell me, this tells me how many elements. Okay? And what is it that tells me? If we say A equals that and B equals that, then A divided by B tells me how many elements. Okay? So that's my pseudocode on how to figure out how many times I need to loop. Okay? So we're going to loop through grades first. Okay, now I know that an integer has 4 bytes, but let's say I don't, right? Because the loop doesn't know. I know because I'm a human brain looking at the fact that I use int, but the computer doesn't know. Okay, so what I'm going to do is I'm going to say, at least the source code. So I'm going to say integer len for length equals, and you've seen this before, size of, and I can just put the variable grades, right? And that gets me the size of the grades array. And I'm going to divide by, now I need to know the length of one of the elements, okay? And if I use the 0 index, I'm never really going to go wrong, right? Because even if there's only one element in it, okay, it's going to be the 0 index. So I'm always going to use that as a default, but I'm going to say size of grades 0 because that's going to be there. If there's anything in it at all, that's going to be there. Okay? Now that should give me an integer, right? Because if there's 20 bytes for grades and there's 5 elements and the size of grades of 0 is 4 bytes, I should get 5 elements. Okay? So what I'm going to do is I'm going to assume I did that right, always dangerous, and I'm going to say for int, and I'm going to use index now, equals 0. Okay, and I'm going to say index is less than length. Index plus plus. Okay, because I don't want to go to the length. The length is 5. Right? But I want to go from 0 to less than that. So I want to go from 0 to 4 by 1. Okay? So I'm going to say printf. And we'll go that. And now what I'm going to do is I'm going to show you a representation of what kind of is in memory. So I kind of like doing it this way. Comma grades of index. And you'll see how this works out because it's kind of cool. All right. So I'm going to print how I visualize the array. All right. So let's see this. And let's go run through the make build. So let's do a make arrays. Got it right. Clear / arrays. I forgot my /n. That's annoying. Printf /n. Control save. Clear. Make arrays. / arrays. Okay? And you can see that it printed out 82, 84, 86, 87, 89. And I made those little boxes around it, if you will, because that's how I think of the data in memory. It's contiguous memory, and I just think that that is a cool way to do it. Okay, it really shows kind of the position. Okay, and so now I'm going to show you a similar thing, but I'm going to actually show you how the index lines up and how I can show you that using for loops for the other array. Okay, so we're going to say I'm going to repurpose len as a variable, so I don't need the int in front of it, or the compiler will tell me I'm trying to create len twice. So I'm going to say len equals size of letters divided by size of letters of 0. Okay. And I need my semicolon. Oops, too far. Semicolon. All right. And now I'm going to say, and let me just do some commenting here like I should. This is going to be calculating length of grades array. And this is printing grades array. Then we're going to give it some space and say calculating length of letters array. And then I'm going to steal this loop. Control C, Control V. And this is going to be index, goes from 0, same thing. But here, what I'm going to do is this is going to be a character. And this is going to obviously be letters of index. Okay. And I'm going to actually Control C, Control V, and I'm going to make this V, and that's a vertical tab. So I'll get a little more space. And let's see if I get the letters out of the array. And there we go. And you can see it's HELLO, kind of as the array holds those letters. Now, obviously, if I want to print the word, I'm not going to have those square brackets, okay? But what I'm going to do is I'm going to show you the index value of each of these letters. And then I'm going to do one more where I show you the ASCII value of the letters by treating them as an integer, okay? So the first thing I'm going to do, and I think I'm going to actually do it on top of this one. I still need length, but I'm going to just back up here a minute. Control C, I'm going to steal that loop again. Only I'm going to call this printing grades index positions. Okay, and in here, I'm just going to print an integer, and it's just going to be index. So I'm going to show you the index position. I'm going to show you literally the value of the indexer. Clear, make arrays, /arrays. Okay, and so you can see the index position matched up with the value at that position. Okay, and now remember, I can treat characters as either the character value or the ASCII value. So I can take this same loop, and this is actually printing letters index position and the letters array, and this is going to be as characters. And then I'm going to steal this one again. Control C, Control V, and this is as ASCII values. Okay? And this is going to be as I, but letters of index is going to stay the same. Okay? Because I want what's in the array. So clear, make arrays, do another clear, /arrays. And there we go. Now, obviously, it blows out because those lower letters start at 97. So it doesn't line up as neatly, but 72 is capital H, 101 is E, 108 is L. I kind of know I'm right because 108 is also L. M and O is 3 letters, so I know I've got it right at 111. Okay? So I've literally printed out the index position, the character value, and the ASCII value, all looping through arrays simply by calculating the length of the array so I know how many positions I need to go with my index variable. So this is a pretty cool way to do things. And as we get into other languages, as you get further into C, you're going to see that you can have arrays of arrays, and you can have two-dimensional arrays and things like that, and that's more for later. So take a look at this video, try to recreate what we've done here, and really get to be where you are familiar with different types of arrays of data. You might do floating points. You can create a string and index through the string positions. There's lots of different things you can play with to become comfortable with arrays. Welcome back. So hopefully you have had a decent introduction to the foundations of arrays. There's a lot you can explore with arrays, and as you've kind of seen from the coding, arrays are very primitive in C. They're not very user-friendly when you want to do things like copying arrays or changing the number of elements in an array, because arrays are basically unchangeable. Okay? The fancy term for that is they're immutable. You cannot change the allocation for an array once you've created it. So if I want to put more elements in an array, I have to create a larger array and then copy those elements into it, because arrays are immutable. That's the way it's built, and that's what we have to deal with. So hopefully you have a little better feel for that. And I want to talk about what's coming up next, because the next video is a little bit longer, and it's probably the most complex of all of the videos we're going to have in this language series. And it is the video that we do on pointers. Now, pointers are variables like every other variable, but they hold memory addresses. So they can be a little bit complicated. So I've created, it's basically almost an hour-long video, and I fully expect you to hit pause a lot. And you may have to play it several times, but that's okay. I want you to take it at whatever pace you can, because if you can really come out the other side understanding pointers, it's going to be a giant leap forward, especially if you're going to move on to college and program in computer science. Understanding pointers in high school gives you a significant advantage as you move into your freshman year of college. Not to mention the fact that by getting understanding of pointers kind of under your belt, so to speak, in AP principles, when you move into CSA and start dealing with Java, even though Java is managed code, that understanding of how memory operates is really going to help you when we get into object coding. So this is kind of a cheesecake video coming up. There's a lot to it, so take it slow, take it easy. If you can, code along with me, and I would recommend you take notes on this one. It's a deeper video, but it's really good information. And I even, at the risk of being confusing a little bit, I make a mistake that everybody makes on purpose, but I make it on purpose to kind of show you where you really need to be careful as you start to understand it. So if it takes you a couple times through this video and you got to go, okay, I get it, why that's wrong, I think it's really going to help, because I kind of intentionally lead you down a path about 3/4 of the way through and then show you why it's wrong. And it's helped people in the past. So I just kind of wanted to leave it that way. And if too many people tell me it's confusing, I'll edit it out. But I kind of wanted to leave it there so that you can see where a lot of people trip up. Okay? So I'll see you after the video.